Yeah, ICC Physics, Chapter 2, Work, Energy, and Power. Okay, we are going to do the numericals of it. So let's see the formula which we are going to come across in this chapter. The first of the formula, work. Work is equal to force into displacement. Okay, this can be also taken as the definition of work. Work is defined as a product of force and displacement in the direction of force. Got it? Work is defined as a product of force and displacement in the direction of force. Work is represented by, always remember, work is represented by W. Okay? Work is always represented by letter W. Okay? Work is represented by letter W. F is represented by letter F, and displacement is represented by letter S. So W is equal to Fs. Are you getting? W is equal to Fs. Now नीचे देखो second formula. अच्छा, W is equal to Fs. You should use this formula when the displacement is in the direction of force. मतलब displacement of the body takes place in the direction of the force. That time you should use the formula W is equal to Fs. W is equal to F into S cos theta. W is equal to F into S cos theta. You should use this formula when displacement is at an angle theta with the direction of the force. Okay, there is an angle, there is a, like, suppose this is the direction of the force. This is, sorry, if this is the direction of the force, and this is the direction of the displacement. So there is an angle theta. This is the direction of force and this is the direction of the displacement. So there is an angle theta between them. Then W is equal to Fs cos theta. For lifting examples, okay, any body which is lifted. So what is the work done? Work done will be mgh. W is for work, m is the mass of the body which is getting lifted, g is the acceleration due to gravity, h is the height to which the body is lifted. So W is equal to mgh. So these are the three formulas for work. Now SI unit of work is joule. It's always represented by capital J. If you want to write the full form for it, it should be always small Joule. Got it? Whereas if you want to write a notation, capital J. CJ's unit of work is Earth. CJ's unit of work is Earth. And what is the relation between 1 joule and 1 erg? You can clearly see the relation is 1 joule, 1 joule is equal to 10 to the power 7 ergs. Okay, 1 joule is equal to 10 to the power 7 ergs. Okay, 1 joule is equal to 10 to the power 7 erg. Now again, you're going to learn about, please have a look here in this, something called power. What is power? Power is work done per unit time. So याद रखो बेटा, power का formula क्या आएगा बेटा? Power ka formula, I'm just writing it here. Power is equal to work upon time. Power is equal to work upon time. Power is equal to work upon time. You know the formula for work, okay? But divided by time, total time taken to complete the work, I get power used, okay? Now, SI unit of power is watt, W-A-T-T, capital W, okay? 1 watt is 1 joule per second, okay? Bigger unit of energy is energy. You'll be learning some formulas later on, but energy, the bigger unit of energy is, nothing but a capacity to do work. So energy is basically work. So SI unit of energy has to be joules. CGS unit of energy has to be erg. But there are some bigger units of energy. They are watt hour and kilowatt hour. What is 1 watt hour going to be equal to? You can see here, children, 1 watt hour, you can see a 1 watt hour is 3600 joules. And 1 kilowatt hour, 3.6 into 10 to the power 6 joules. Okay. Now, After going through these formulas, let us try to solve some problems, okay? So we start with the children, look at it, okay? Now, you can see here, children, it says, okay, 1 minute. So sorry, let me adjust it. Okay, I'll just 1 minute. Let me adjust the screen, children. I'll just take some extra time and then we'll get it over. Okay. Okay. Now got it. Again. See, a body of, you can see here, children, what it says. Okay. A body, when acted upon by a force of 10 kgf, a body, when acted upon by a force of 10 kgf, gets displaced by 0.5 meter. A body, when acted upon by a force of 10 kgf, force applied is 10 kgf. It gets displaced by 0.5 meter. Calculate the work done by the force. When the displacement is in the direction of the force, second at an angle theta with the force, and third normal to the force. Got it? So very simple, children, very easy questions. Just have a look here. Okay, what is f? F is equal to solution, मतलब आंसर लिख रहे हैं. F is equal to 10 kgf. Now this 10 kgf, this is not an SI unit. I convert it into SI unit. Got it? So kgf को convert करना है न्यूटन में. तो ये 10 को g का वैल्यू से मल्टीप्लाई करो. g का वैल्यू कितना है? 10 दिया है. So 10 into 10. Okay? मतलब 10 kgf multiplied by 10 Newton per kg. So ultimately क्या होएगा बेटा? 10 into 10 equal 100 Newton बन जाएगा. मतलब this force was in kgf, I got it in Newton. Okay. Now what is the displacement given to you, children? Displacement is 0.5 meter. Now first one, when the displacement is in the direction of force, displacement is in the direction of force. So मैंने W is equal to Fs बताया. Whenever displacement takes place in the direction of the force. See, displacement takes place in the direction of the force. You can see here the first question, okay? The first question is, first part of the question is, when the displacement is in the direction of the force, W is equal to Fs. So क्या आएगा? We put the values, beta. How much is F? 100 Newton. How much is S? 0.5 meter. तो ये कितना आएगा बेटा? 50 joules. Got it? It is 50 joules. So remember, first one, work done is equal to 50 joules. This is first answer. Second answer, when the direction, when the displacement is at an angle theta with the direction of force, मतलब theta is equal to 60 degrees beta. So W is equal to F into S cos theta. F is how much, children? We know F is 100 Newton. S is 0.5 meter. And cos of theta is the angle between the two is 60 degree, angle between the displacement and the force. So this becomes 100 Newton into 0.5 meter into 1 upon 2. So what will happen? This 2 will get cancelled with the 100 to 1 time and 2 50 times. So 1 digit after decimal goes off 25. So this is 25 Newton, correct? sorry, 25 Newton meter, that is nothing but 25 joules. It is nothing but got it? 25 joules. And what is the third part of the question? When I look at the third part, theta is equal to 90 degree. Theta is equal to 90 degree. Okay. Theta is equal to 90 degree. So what will happen? W is equal to F into S into cos theta. So F का वैल्यू तो अपने को मालूम है बेटा. F का वैल्यू कितना है? 100 न्यूटन. S का वैल्यू मालूम है 0.5 मीटर into cos 90. Theta is 90, cos 90. Now cos 90 is 0, 100 Newton into 0.5 meter into cos 90 is 0. So when you multiply the whole thing, you get 0. Got it? So remember, beta, in the first one, the work done was 50 joules. In the second one, the work done was 25 joules. In the third case, the work done is 0. I hope everybody understood me here. Now, yeah, let's see the second one. A boy of mass matlab M, a boy of mass 40 kg, climbs up the stairs and reaches the roof at a height of 8 meters. Roof matlab height is 8 meters. In 5 seconds. In 5 seconds. T कितना है? Okay. So what happens? Calculate the force of gravity. See, force of gravity is nothing but weight of the boy. Force of gravity will be nothing but beta weight of the boy. And weight of the boy कैसा निकालेंगे beta? M into G, mass of the boy into acceleration due to gravity. What is the mass given to you? 40 kg. And what is the acceleration due to gravity? 10. So ये कितना आएगा बेटा? 400 Newton. Now, the second one, work done by him against the force of gravity. What is the work done, beta? Work done is equal to mgh. I told you, whenever you want to lift it, you're lifting it against the gravity. So that is what they're saying. Now this is nothing but m into g. M is how much, beta? 40. G is how much, children? 10. And what is height? Height is 8 meters. So 3,200 joules. I go into the third part. Okay, work done by the power spent by the boy. Now, power is, please here, power is work upon time. Power is equal to work upon time. Now, what is work here, children? The work done in lifting example. Got it? See, work done by him against the force of gravity. Then power spent by the boy. That means here, 3,200 joules work he does in how many time, Peter? He does this in 5 seconds. Okay. So when you see here, 5 6 are 30, 5 6 are 30, 20, 5 4s are 20. So this is watt. So power spent by the boy is 640 watts. I hope people understood me here, children. Not a difficult sum at all, okay? Question number 1 and question number 2 over. Now we go to question number 3, okay? We go to question number 3. Yeah. Now question number 3 says, the work done The work done, 1 minute, children. Just 1 minute. 1 minute, children. Yeah. A man spends 6.4 kilojoules energy. Okay. We come to this question. Please have a look here. A man solution. A man spends 6.4 kilojoules of energy in displacing the body in the direction in which he applies force in 2.5 seconds. That means a man spends 6.4 kilojoules energy. That means he has work done. How much work has he done? He has done a work. He has done a work equal to, children, 6.4 kilojoules. Now, always remember, this is not an SI unit. This is a higher unit. Kilo नहीं मांगता मेरे को, joules मांगता है. So K मतलब 1000. So 6.4 into 1000. Okay, the whole thing joules में होगा. Joules as it is. So how much I get, children? 6.4, 6400 joules. Got it? So calculate now. See here, the first part of the question is, so man spent 6.4 kilojoules of energy. That means 6,400 joules of energy in displacing a body in the direction in which he applies in 2.5 seconds. How much? Total, how much time he has taken? Total time is 2.5 seconds. Now, first part of the question, the force applied, okay? The force applied by this man in the force applied, and then he wants a horsepower, a power spent in horsepower, power force applied. So W is equal to okay. Just see, our children, a man spends. Once again, I'm reading the question, children. Okay, a very simple question, but let's see. A man spends 6.4 kilojoules of energy in displacing a body by here. I missed out something. That is what I was wondering. Okay. In displacing a body by 64 meter in the direction of the force. In the direction of the force. Got it? You can see here. So S is 64 meter. First part of the question, they want me to find W force applied. W is equal to Fs because here the displacement is taking place in the direction of the force. So W is equal to Fs. W kitna beta? 6.4 into 1000, that is 6,400 joules is equal to force I don't know, and that is 64 meters. So when I do it, what I get, force is equal to, please have a look here, children, 6,400 divided by 64. So how much you get, children? 100 Newton. So what is the first answer? Force applied is 100 Newton. Now I go to the second one. Got it? The power spent by in horsepower. So power is work upon time. Now, what is work here? Work here, when you look at it, children, he has done 6,400 joules. And how much time he's taking? He's taking 2.5 seconds. So what will happen, children? 6,400 into 10 upon 25. 5 twos are 5 fives are 5 one time, 5 2 times 10, 5 8 times 0. So how much you get? 2560 watts. Got it? This is it. Got it? Now I want it in horsepower. So 1 horsepower is 746 watts. 1 horsepower is equal to 746 watts. So naturally, what will happen, children? So 1 minute equal to 2560 into 7. So when you multiply this two, got it? You get it in horsepower. Got it? You get it in horsepower. So remember, children, when you do multiply this two and try to get it, okay, in horsepower. So how much you get? When you multiply in your RAP 2560 multiplied by 746, okay, it will become 1 horsepower is equal to 746 watts or 0.746 kilowatts. So whatever it is, children, you will be getting your multiply and see and how much you get. 2560 multiplied by 746. 0, 36. 6 y's are 30, 33. 6 2's are 12, 15. 4 zeros are 0. 4 6 are 24. 20, 22. 4 2's are 8, 10. 0. 7 6 are 42. 39. 70. 0, 6, 7, 9, 10. Okay. Okay, children. What do you get it? Okay. Now go to next.